Hello, I'm Alex McDowell. Welcome to How the British Invented the Metric System Part 2. In Part 1 I explained how English Bishop John Wilkins invented metric units of length, weight and volume. I'll now show how the British invented the candela or candela for lamp brightness and the kelvin for temperature. Count Rumford, an American-born British physicist, pioneered photometry, i.e. the measurement of light intensity. He invented the standard candle as a unit of luminous intensity, and this was the forerunner of the candela that we use today. I've recreated Rumford's photometer. I have a screen. The green pencil is my shadow stick. On top of the upturned mug is a candle, which will play the part of the standard candle. Rumford's standard candle used spermaceti wax and was made to consume 7.8 grams of wax per hour. I've not used spermaceti because it comes from sperm whales and environmentalists would have a fit. I've just used an ordinary wax candle. I have an electric light and I am going to see how many times brighter it is than the candle. Rumford used his apparatus to compare the brightness of oil lamps to his standard candle. I light the candle. I then light the bulb. Of course I should have done this before killing the room lights. Because I have two light sources, the pencil casts two shadows. I move the electric light back until the two shadows are equally dark. At this point, the light intensity from each source is the same at the screen. The fact that the two light sources are slightly different colours makes it harder to judge when the two shadows are equally dark. Also, because the spectral responses of our eyes vary from person to person, different people will get slightly different results because of the colour difference. The way this photometer works is by the two light sources illuminating each other's shadows. I measure the distance from each light source to the other's shadow. The distance from the candle to the shadow on the right was 42 centimetres, and the distance from the electric light bulb to the shadow on the left was 61 centimetres. The ratio of the intensities of the two light sources is the ratio of the square of the two distances. And when we do the calculations, we find that the bulb is 2.1 times brighter than the candle. In 1948, the candela or candela was born. The pronunciation varies even between dictionaries. Whichever way you pronounce it, it was derived from the standard candle that was pioneered by Rumford, the British physicist. The British physicist Lord Kelvin proposed the absolute temperature scale, whereby temperature is defined by the number of degrees Celsius above absolute zero. Today we call this the Kelvin scale. For example, water freezes at 273 Kelvin. Absolute zero is the coldest temperature possible. Although the Kelvin is the official unit of temperature in SI, most of us use degrees Celsius in everyday life. The Kelvin scale is used mainly in science because it makes some calculations easier. On this light bulb packaging you can see 3500K. This means 3500 Kelvin and is the bulb's colour temperature. It means that the light from this bulb is the same colour as a black body at 3500 Kelvin. Many hot objects approximate to black bodies, for example the Sun. This light bulb packaging has an explanation of the Kelvin scale on it. The colour temperature of light bulbs is one of the few cases of the Kelvin scale being used in everyday life. So there you have it. The Kelvin and the candela were invented by British physicists.